Imagine a world without ice. No frozen poles, no towering glaciers, and no snow-capped mountains. Instead, lush rainforests stretched across the Arctic, strange creatures roamed tropical swamps, and oceans swallowed entire coastlines. This was the last time Earth was iceless, a time when our planet looked nothing like it does today. But what caused this ancient world? And could it happen again in our future? Is the Ice Age still going on? When people think of the Ice Age, they often imagine a frozen world filled with mammoths, saber-toothed cats, and endless sheets of ice. Movies and books usually make it seem like something that ended long ago, but the truth is far more surprising. Scientists say we are still living in an ice age today. By definition, an ice age is a time when there are permanent ice sheets in both the northern and southern hemispheres, and since Greenland and Antarctica remain covered in massive glaciers, Earth still qualifies. Some experts even argue that the very presence of permanent ice anywhere on the planet is enough to count. Officially, we are in the Quaternary glaciation, which began 2.58 million years ago and has never fully ended. Instead, it has gone through warmer and colder cycles. Knowing this challenges the way we think about Earth's climate. It reminds us that we live in a rare, icy chapter of our planet's long story. When was Earth last iceless? So, when was Earth last completely free of ice? Not just warmer than today, but truly iceless. To answer that, we need to travel far back to the late Eocene epoch, about 40 to 34 million years ago. During this time, the world was incredibly hot and humid. Crocodiles swam in rivers in Antarctica, palm trees grew in Alaska, and Europe's weather felt more like the Middle East than what we know now. Global temperatures were 5 to 8 degrees Celsius warmer, and sea levels were around 70 meters higher than today, swallowing coastlines and leaving only scattered islands where continents used to be. Entire regions like Florida were underwater. This world was lush but unstable, with storms, rising seas, and constant changes. Life had to adapt quickly, making it an age of experimentation and survival. The largest, predators, before the ice. The warm oceans of the late Eocene were home to some of the most terrifying predators to ever exist. Basilosaurids, the ancestors of modern whales. Unlike today's gentle filter-feeding giants, these were active hunters with sharp teeth and streamlined bodies built for speed. They dominated oceans everywhere, from shallow seas to deep waters. And fossils have even been found in Antarctica. Basilosaurus, the most famous, stretched up to 18 meters long and had jaws strong enough to crush bone with ease. Its stomach contents show that it hunted sharks, fish, and even other whales. The forefather of Megalodon. Swimming among these terrifying whales were giant sharks that would one day give rise to the legendary Megalodon. The Otodis family included enormous species, such as Otodis auriculatus, which could grow up to 9.5 meters, as long as modern killer whales. Another, Otodis obliquus, reached about 12 meters, comparable in size to today's whale sharks. These sharks had huge triangular teeth designed for tearing flesh, making them top predators in every ocean. They likely battled with Basilosaurus and other giant whales, turning the seas into battlefields of predators. Though these specific species went extinct, they left behind a legacy. Their evolutionary line continued to grow bigger and more specialized, eventually producing Megalodon, the largest shark to ever live, and perhaps the most feared predator in history. What we were doing at the time. During the late Eocene, primates were already well established. While humans were still millions of years in the future, monkeys and early primates thrived in the dense forests that covered much of the land. There were more species and greater diversity than today, since thick jungle provided endless opportunities for adaptation. Rodents, insect eaters, and small ungulates also flourished, filling countless ecological roles. This period was critical for mammalian evolution because it set the foundation for future dominance. Without the primate boom of the Eocene, our own branch of the Tree of Life might never have appeared. The reptiles' last attempt to stop mammals. Although mammals were rising, reptiles still held powerful positions as predators. Terror birds, massive flightless hunters with sharp beaks and strong legs, dominated in many regions. They could run at high speeds and deliver devastating strikes. Other giant birds, like enormous penguins and flying species with vast wingspans, these creatures showed that reptiles and birds were not ready to give up their dominance easily. For much of the Eocene, mammals and reptiles competed side by side, each taking advantage of different strategies for survival. Mammalian predators before the ice. Mammals were quickly catching up. Fierce hunters like hyaenodons, bear dogs, entelodonts, nicknamed hell pigs, and nimravids, false saber-toothed cats, began to spread. Many had massive heads, bone-crushing jaws, and ambush strategies that made them top predators. Entelodonts in particular were frightening, huge, aggressive animals that acted as both hunters and scavengers. In South America, Sparassodonts filled similar roles, while nimravids developed long, saber-like teeth, imitating the cats that would later evolve. These predators rivaled lions and tigers in size and strength. For the first time since the dinosaurs, mammals were competing directly with reptiles for dominance, and in many cases, winning. What started the Ice Age? The warm Eocene came to an end when powerful geological and atmospheric changes reshaped Earth. As the supercontinent Gondwana split apart, Antarctica drifted into its current position at the South Pole. Isolated from warmer waters, ice sheets began to spread across its surface. At the same time, carbon dioxide levels in the atmosphere fell, reducing the greenhouse effect that had kept the Earth warm. Ocean currents shifted as new seaways opened, reinforcing the cooling trend. These forces worked together to transform the hot, stormy planet into one entering its first ice age in millions of years. Plants and animals had to adapt quickly to colder, harsher conditions, beginning the long transition into the Ice Age world we still live in today. When will the next iceless period start? Today, Earth remains in an ice age because massive ice sheets still cover Greenland and Antarctica. The last time our planet was truly ice-free was about 34 million years ago. Predicting the next iceless period is difficult because it depends on both natural cycles and human impact. Normally, Earth would stay icy for millions more years, with shifts in orbit and carbon dioxide eventually leading to warming. But human activity has sped up the process. Greenhouse gas emissions are raising global temperatures, and if this continues, the ice sheets may melt much faster than they would naturally. Some scientists warn that this could bring about a new, iceless Earth far sooner than expected. A reminder that our actions today may decide the planet's future climate.